Hey adapters, I'm Doug Parsons. I'm a partner at Cimpatico Studios where we live stream conversations about complex business and social challenges with professionals like yourself who are working on the same issues. Our shows are live streamed in front of a global audience of your professional peers on Cimpatico.tv. I'm building a new type of online community for professionals like yourself on the Climate Adaptation channel. If you're a regular listener of my America Adapts podcast, I think you'll find that we're taking our conversations about important problems, policies, and solutions to the next level here. And if you're interested in being a guest, we'd love to hear from you. And now join us for this latest episode. Hey adapters, today our guest is Jan Skjoldhammer. Jan is a former officer, airline captain, display pilot, inventor, and entrepreneur. Jan has now spent more than 13,000 hours and most of his life savings in developing a breakthrough wave power concept, NoviOcean. Jan has been recognized as Sweden's Mission Innovation Champion of 2020. NOVIGE AB is developing a wave energy converter called NoviOcean, which generates electricity, produces hydrogen, and can help reduce shoreline erosion. Jan will introduce us to NoviOcean's unique patented technology, will show us how it's more cost-effective than previous wave energy solutions. Hey Jan, welcome to the show.
Thank you, Joe. Looking forward to the talk and hope I can enlighten the audience somewhat about wave power and perhaps specifically about what we're doing.
Well, wave power, just, as where we'll talk about it, it hasn't been as developed and doesn't get the sort of attention, but it always excites me. Whenever I read some sort of science article like they're working on this, I'm like, please, let's do this. But before we jump into that conversation, I'm checking in with my guest in COVID-19. How's it impacting your work? What's sort of going on in that respect?
Actually, not so much. Most of our team of about 10 persons are working from home anyway. We did go to meetings much more before, so now it's basically Zoom calls all around. But we just keep on working like earlier. Less travel, which is in one way more efficient. And so far, the interest for what we're doing is still high. I think COVID has been taking some of the attention from climate, issues for a while. But when the summer season comes in Australia, and you have more floods and hurricanes in the U.S., will shift back a bit. So far, we still feel that we have support from the authorities and the companies around us. Yeah.
Okay, so before we jump into the technology that you've developed, in the past couple decades, we've seen a lot of failed ocean energy concepts, and a lot of that has to do with cost. Can you kind of give us a brief history of some of those things?
Yes, many concepts have worked. They do give some power. Some break down due to the harsh environment, but many give power. The problem is that most of them have a weight of from 500 tons to 1,000 tons per megawatt hour. Capacity factor is about 25%. That means that you get about 50 kilowatt for 1,000 ton of material out in the water. That means you can power one large truck with 1,000 tons of advanced, heavy, complex material out in the sea. It
Wow.
doesn't make sense, does it? It's just too much stuff out there, which has to be deployed, transported, and maintained. It cannot be economical. So that's the main thing. Our concept is down to about 120 ton per megawatt, which is much less than the other ones. And then it starts to become into realistic numbers. So that's one reason. The other concepts are very often very complex with totally new concepts or pieces and parts and the way they function. And that makes the durability a difficult question because they do break down. We have looked around that and put up some requirements when I started with this, and it was that it should be giving lots of power, be simple, few parts, made out of parts and components that have been proven through time, and all in all, should be light. I sat down for 1 year drawing all sorts of concepts. I had the float in mind since I was 25, by the way. But I went through the chains, the gearboxes, those actuators, and lots of different normal stuff. And they all went to my trash can because they collided with my requirements. I finally was happy after 1 year when I had this concept, which is a hydropower plant at sea. It's just a normal hydropower plant taken out to sea. And that is simple, durable, few and light parts, and it's well proven.
Okay, and so you're working with wave power and versus tidal power. Maybe you could distinguish between the two really quickly.
Yes, tidal power works with the horizontal movement of a water mass. Normally, you have something underwater with a propeller that goes around like this when the water is moving past. The tidal is restricted to some areas around the world where you have lots of fast-moving water masses. Wave power, I think, is about 7 times more potential than tidal power, and has to do with the vertical motion of the waves mostly, or the circular motion, depending on what kind of concept you have. The potential is, by the way, about 7 times larger than all wind power today, about twice of nuclear. So the potential is quite a bit.
Well, okay, so there's all these challenges working in marine environments. As you mentioned, simplicity is always an important one because everything just starts to degrade. But why do you think NoviOcean will be successful despite this kind of history of having challenges working in the marine environments?
Well, what the company did when we had this set out, we hired a third party for about $80,000 US to do very complex design studies and performance studies, and they came out with a very extremely low cost per megawatt hours, which shows that we're starting out with a cost which is 25% what wind power had from start, 25%. And given then the same learning curve, it might sound strange, but then we're going below wind power in cost per megawatt hours in some years by normal evolution, because you have a learning curve there. Of course, then first, of course, below wind power offshore, which has a higher cost than wind power onshore. But the number said that we should come down to about 3 cents per megawatt hours by a long time evolution. And that is below basically all fossils and basically all energy source or energy productions today.
Okay, so I'm trying to visualize the actual product too, and you've shared some information here with us. But you'd mentioned how much energy is actually produced from an individual unit. So kind of explain to us, like in an ideal situation when it's being used. I mean, is it going to take 500 to produce energy for a city? What's sort of when it looks like that way?
Yeah, each unit is behind me here. This is just a CAD drawing, but we have it also tested both offshore and in the wave tank. And each unit gives up to 500 kilowatts of power. And the average power, depending on the site, should be about 50% of that. And that powers about 800 homes per unit. So it's just by multiplying up, you can get it to power quite a bit of industry or houses. And we have in the longer product line, we have 2 megawatts and 5 megawatts possibility as well. We'll start with 500 because it's way faster into the commercial step by having this price.
I lost you there just a sec. Could you just repeat that last bit? I lost you just a little bit.
Oh yeah, sir. Well, this size you see behind me.
Yep.
The first one will be 500 kilowatt of rated power. But by the evolution and by time, we will make larger units up to 2 megawatt and 5 megawatt. But we're starting out here because it's quicker to get into the commercial phase by having a smaller unit.
So what do you imagine like a customer would be? Would it be like a local government? Would it be a business? And so that energy is being produced, but it needs to come into a grid. And how did you thought through that way? How are they taking advantage? And you're like, all right, we want to buy 100 of these because we need that amount of energy. And then obviously, who owns the ocean where you might put those things in? How does that all kind of fit together?
Yeah, the first of all, the paperwork, you have to rent the ocean area from the nearest kind of community. And that means you go through a constant process. You apply to rent this area for the next 20 years, for instance, to be in that section of water, just like wind power offshore does. It's the same thing, actually. So we do that for 1 or 2 years, arguing about different things, and you have to prove that it is environmental friendly, etc., etc. Then the customer will normally be a utility that wants to sell electricity stable and off-phased with wind, which is an advantage. Because today the grids are having problems with the sun power and wind power going up and down. So the grids are sometimes underpowered, sometimes overpowered. And since wave power is off-phased, it comes in later than wind power. It will help to stabilize the grid
Hmm.
more. So it's a good thing for the grid owner and for utility companies, because it will be easier for them to satisfy the customer by always be able to power up to the requirements. And then it will just produce at the most power it can. In our case, it will give 500 kilowatt in a 3 meter wave, which is about on the winter wave medium range. In the summer on your west coast, you're down to about 1.5, 2 meters. So then it will be slightly lower. But you need more power also in winter, so it is kind of practical in many ways.
So I didn't quite catch those, but how far from the coastline would these be? I mean, is it just you can in eyesight, or would like some of the wind turbines are much farther out?
That's a good question. Wind power offshore is out to sea about 30 US miles. Because of the height, they go up in the air about 250 meters, and no one wants them having close. And also, they need to catch more wind, so they have to be out there. Will be depending on the depth of the water, will be from about 30 to 80 meters depth, and that is normally somewhere from 500 meters to 5 kilometers out, so that the deployment phase is easier. Not to say the maintenance is also easier. Will be hardly visible because it's just like in our case above water about 7 8 meters. It's just this float over here will be about 35 meters long and about 3 meters high on the sections, a bit higher in the center. And we'll also offer, we'll have most likely have a fountain, lighted fountain on top, so it's visible. It just looks nice. Most
Okay,
people like a fountain, so we'll do that as well.
interesting. All right, we alluded to that working in unison. If these things are all out there, it can actually prevent a bit of coastal erosion.
Yes, it is, because when you extract power from a wave, you're kind of killing the wave. So the more efficient you are, the more you dampen the wave. So let's say if you are on the California coastline where you have this problem, if we are like sausages along the coastline like this, we will take around about 30% of the energy of the wave. So at least for the harsher waves, that we can save and reduce the coastal erosion. So anyone in California is quite happy to support us, and will help you keep your houses staying on the cliffs.
Well, are you reaching out to the surfer lobby? I don't think the surfers would necessarily appreciate losing the wave.
No, what I'm reaching out to in some way is that we need, of course, to have this coming forward as quickly as possible. And right now, we're spending about 50% of our time writing grants to get money from the European Union, from Sweden, from England, all those stuff. It takes a lot of time. One application might be 100 pages long. So we'll probably be able to, over the next half year, get about 60% of the cost of the first unit, done by grants. And then we need about 40% more, which is only about $2 million US dollars from a private side. So we're looking at, if possible, it would be great to have philanthropists and contributors that would like to lend us some money or to give us some money if they want to see us come quicker in the water to save time for the climate. They're most welcome to contact us and be a part of our team in some way, or advisory board or whatever. That would be great for us. So anyone listening, if you have friends or contacts, tell them to call me.
All right, good investment opportunity. And we create a wall within Cimpatico for your episode, and so we'll have all this sort of information available too for people watching it even after this. And I'm wondering, the technology, it seems like it's there. When you get the resources and the funding and you try to scale it up, what's sort of a demonstration project? Because in theory, for this to kind of work at the level you want to, do you want to start with 10 that are out there? Or is it 300? Like what, and this is, I'm talking about, I guess, even through the trial phase, what's sort of the plan there?
There's like a normal procedure in marine energy. You build a smaller scale, like we have. We don't see it right here, but you have it on the page, I think. About on the visual we sent out on the invitation, you can see the real one in the water, which is a smaller 1 to 5 scale. You test that one first offshore and in the wave tank, and perhaps modify some. Then you build a large unit. So we'll make one large unit now, when everything is in place. And then you make one unit, which you place normally in a test zone somewhere. There are many test zones in Europe, in Scotland, in Ireland, Portugal, France, Spain, etc. And you also have one up in where is it, northwest of I think it's outside Seattle somewhere. I've forgotten the name right now. So which is coming up. It's not ready, but you are also coming on there. TET is the governmental side of that. Well, you test one there, put it in the water, test it for about 1 year normally, and you get the numbers, modifications, and at the same time you work with certifications with Lloyd's or with other companies like that. And that's done. You normally place out 3 units somewhere, like a small array to go together. And then you want to prove that an array functions together, because there are some advantages when one goes up, the other one goes down, etc., etc. So when that is done, you will have it fully certified and bankable. That means you can take a loan to build the next ones. So perhaps the next customer says, we want to buy 5, and then you're like a normal business. You can say, well, we want to loan so much money to build this next array, and the customer will pay some upfront, some during the deployment phase, etc., etc. So then you enter the business. So basically, first one small unit like we have now, sometimes more small units, but first 500 for us, then 3, and then the commercial side.
Okay. Well, I got a question coming in from the chat room here. It's from Ken. Would large-scale NoviOcean hydropower plants disrupt sea life ecosystems?
It's a very good question. There have been done quite a lot of research on that, both on the electrical cable, which is used by wind power, and also by other wave power systems, especially also with tidal power with these large propellers. And it seems that slow moving object is very easy for the sea life to get away from. So they've seen minimum negative effects on that. The wind power turbines, as you might know, they go very quickly around on the tip speed. I think in Germany they find that every wind power plant kills about 47 kilos of insects every year. That's kilos of insects. That's a huge amount. So it seems that ocean energy should be much nicer to the environment than wind power. We need both. So don't misunderstand me, but so far it looks very, very good for ocean energy.
Okay, and I missed this question that was related to it from Kayla. She was talking about wildlife, but she also included, pollution that's in the ocean that isn't flowing necessarily like it should be. Do you think it would be a significant there's a lot of plastic in the ocean. Could it gum up the nature of how you even generate energy if
Yeah, very
pollution?
good question as well. Yeah, I like it. Well, our system is sort of a closed system, so we don't pull in water from the outside. So for us, it shouldn't be any major problem at all. For the turbines and what are the tidal powers, they have some challenges there. Yes.
Okay, this is a little bit of a fun comment, but Ken was saying, don't forget windmills cause cancer. I'm assuming your technology doesn't cause cancer. Have you heard this before?
Yes, it's actually quite relevant in Germany. I know, Germany has many wind turbines, and recent years they have been stopping up that quite a bit, or using the new uh, arrays or parks, because people complain about the sounds,
Okay.
and also about different radiation stuff. So it seems that we might be a very nice complement, and perhaps even more relatively with the wind power.
Okay, but just want to make clear, wind power I don't think there's any evidence showing cancer here.
Yeah,
Um,
no.
uh, all right, I'm looking at the chat room. There's just some commentary going on, but a question, I guess, for you is, the role of NoviOcean and I'm assuming that the U.S. market is something that you want to break into, even though you're in these kind of early stages. But more broadly, what could NoviOcean offer the U.S.?
I think now many companies in the US are looking towards new markets, and they want to look to see, can we work in the renewable energy field, and they don't know what can we do. They can perhaps build ships or oil rigs, or they can build trucks or whatever, but they don't know how can we can compete with Tesla, can we? So they're looking for that. What we're going to do to make this go into the thousands around the globe quickly, that we will sell very price-worthy licensing to any industrial company out there, with the possibility to build sections or large sections of what we do. They will have the recipe, the CAD drawings,
Hmm.
the material selections, the whole thing from us. You can build it, deploy it, maintain it in your region, in the US, South America, South Africa, Australia, whatever. In this way, we can have many companies around the world producing our concept.
Hmm.
Should we do it ourselves? It might be more money to it, but I don't care. I'm doing this to the major reason I do this is for the climate. It will be enough profit anyway. So I want many companies, typically shipyards, large industrial companies, could even be the big ones like Siemens, Hitachi, GE. They come in as well to build this, deploy it, maintain it, all for a low fee. We have the patent rights, and we'll have how to do it. And to understand how we'll be doing, we're selling most of it as a license. We'll keep a little bit, 20% as a plugin, just to make sure we have control of what we're doing.
And this, you should have just answered this. Kenneth was saying, who's the ideal buyer of NoviOcean in terms of what types of organizations and agencies? But you just sort of explained that you're trying to just get it out there in these sort of targeted areas. And we had a follow-up question. Could NoviOcean power some of these offshore server farms that Google is testing out? And we were sort of chatting about that previously. So it could power those things?
Yes, very good, very good. It can do more, because on board there, even on the smaller one, on the 500 kilowatt, it measures about 35 times 11, 12 meters. So we have more than 300 square meters times 3 meters height. So it's about 800 cubic meters of area. What we can do for Google, for the Bitcoin guys, and the other ones that consume lots of power, they can have their servers on board. We produce directly all they need of electricity, stable 24/7. They have cooling, and they have the space on board to do this, instead of burning fossil fuels in North China to power their servers. So it should be a possibility. I know Microsoft had tried already, I think, somewhere up north, a smaller unit underwater, partly underwater. So it is definitely possible. Yes.
Okay, so we're at the end of our episode, and I guess my last question to you is, what's next? What's the immediate future for you?
Just to get the grants coming in, and then to start designing it, the full scale, and building it, constructing it, deploying it. It's a 2-3 year event coming up, but that's what we're doing, and of course attracting more people to it. Should I explain more about how it functions, or do people want to know more about the basics of it?
Well, I mean, we sort of kind of cover some of the basic technology too. We are sort of that we keep these episodes a certain length, but maybe that's a future episode. I think this is something we'd like to keep talking about with you. Maybe the focus of a future episode is you want to just kind of dig into the actual technology of it all.
Sure. Definitely. It's also on our homepage. You can just dial in NoviOcean on the internet. You will see more of it. You will see a video goes up and down in the water, and it's a turbine spinning around. It's a Pelton turbine. So you will find information if you like. It's just look for us. You will see much more.
And so the movie that we kind of had showing as you and I are talking, there's schematics of the technology and stuff people were kind of seeing as you were talking. So I think hopefully
Right.
they get a
Yeah.
basic idea here. All right, this is great. Again, love to have you on, and I think as you go through these different phases, I think it'd be a great story for you to kind of tell, like, this is where we're at right now. So I'd certainly have an open invitation for you to come back on. But no, thanks for coming on, and I want you to hold on. I'm going to take you into just chatting to wrap things up, but let's close out this episode. But thanks again, Jan, for coming on.
Thank you for having me.
All right, just one second.